we have to find the sum of geometric progression. We have given the first term of the sum a1 is 1, the second term is 1/2, the third term is 1 over 4, and the last term, so we can write an, is 1 over 64. To find the sum of geometric progression, we will use formula that Sn, sum of first n terms of geometric progression, is a1 times 1 minus r to power n over 1 minus r. We have the first term of geometric progression. We need to have r also and n. So the r is common ratio. What is the r in the geometric progression? Is constant number by which we multiply first term to get the second term to get the third, and so on. So to calculate this r, we have to take two consecutive terms and divide the second one by the first one. So let's use second and first, so it will be a2 over a1. So this is equal 1/2 divided by 1, so this is 1/2. We have r, the common ratio. So what else we need? N. Because we have given the last term of our geometric progression, so let me remind you formula for the n term of geometric progression. An is a1 times r to power n minus 1. We have an, we have a1, r. Our unknown is only n. So we can write, we will substitute an by 1 over 64 is equal, a1 is 1 times r is 1/2, of course, and we have r to power n minus 1. So our unknown is only n in this equation. So 1 times this expression, so will be still the same expression, so we copy the left side, and we have 1 over 2 to power n minus 1. What else? Because we have here in the numerator 64, and we know that 2 to power 6 give me 64, so I can rewrite that this is 1 over 2 to power 6. This is equal 1 over 2 to power n minus 1. I want to change this equation to have the same base. We have 1 over 2 to 6 power. 1 to 6 power give me still 1. So I can rewrite that this is 1 to 6 power, because it's still 1, over 2 to 6 power. This is equal 1/2 to power n minus 1. We copy. What next? 1 to 6 power, 2 to 6 power. So we can write that this is 1/2 to 6 power. So this is equal 1/2 to power n minus 1, because we have the same base. So we can forget about the base and we compare only the power, when the left side will be equal to the right side, when 6 will be equal to n minus 1. So we got equation with linear equation with one unknown. I will move -1 to the left side, so we have 6 plus 1 is equal n. So we have that n is equal 7. So we have 7, we have n, we have a1, r. So we will now use this formula for the sum, and we will calculate the sum of our geometric progression. So Sn is equal, let me copy this one more time, a1 times 1 minus r to power n over 1 minus r. In our example, we calculate that n is 7. So we have the sum of 7 first terms of geometric progression is a1 is 1, and in parentheses we have 1 minus r is 1/2, 2 power n is 7, close parentheses, over 1 minus 1/2. So this is equal 1 times this expression, it will be still the same expression. So we have in parentheses 1 minus, and we have 1/2 to 7 power. So 1 to 7 power is 1. 2 to 7 power is 1/28. And we have 1 minus 1/2, so this is 1/2. So this is equal 1 minus 1 over 1/28, so it will be 1/27 over 1/28. We changed 1 to fraction 1/28 over 1/28, and 1/28 minus 1 is 1/27, and the numerator we copy, over we have 1/2. Division of two fractions, so we copy first fraction 1/27 over 1/28. Division sign we change to multiplication, and we have to flip our denominator, so it will be 2 over 1. So this is equal, we can reduce 2 with 1/28 is 64 and 1, so we have 1/27 over 64. This is sum of our geometric progression.